Hi, this is Mrs. May. We're going to continue our looking at graphing linear equations, but this time instead of using a table, we're going to be using y and x intercepts. So to review from last time, and this is a warm-up problem that we'll talk about in class, so if you can pause the video and take the time to complete this. We're looking at creating a table. Remember your x and y is your domain and your range, and create a graph from this. So go ahead and pause your video, and we will do this warm-up in class. X-intercept, y-intercept. We've talked in class about how the y-intercept, when we're talking about the slope-intercept form, is where the line crosses the y-axis. The x-intercept, no different. X-intercept vocabulary just means this is where the line is crossing the x-axis. So the x-intercept, in this case, will be located here, where the line is crossing your x-axis, and the y-intercept is here, where it's crossing your y-axis. So take a minute, maybe you want to draw yourself a picture or write that out in words. We can graph a line. This is what we're looking at for today, looking at graphing a line using the x and y intercepts. Remember that if your x is equal to 0, that is going to give you that y-intercept. And when your y is equal to 0, that's going to give you your x-intercept. When you're looking at this equation, 3 times x plus 2 times y equals 6, you can simply substitute in 0 for your x. So that gives you an equation 3 times 0, okay, it's a little messy, plus 2 times y equals 6. And we know that any number times 0 is equal to 0. So really what this leaves you is 2y equals 6. And when we divide by 2 on both sides, it gives you y is equal to 3. I'm going to put that in here. So in other words, when we zero out your x, and you no longer, that's not part of the equation anymore, we're left with 2y is equal to 6. When you do the equation, you end up with a y-intercept of 3. You can do the same thing to find your x-intercept, only this time you're going to substitute in the 0 where the y is located. So we have 3x plus 2 times 0 is equal to 6. Anything times 0 is equal to 0. That gives you 3x equal to 6. When you divide by 3 on both sides, it gives you x is equal to 2. So my x-intercept is at 2, 0. So I'm just going to erase this equation and get that out of the way for you. So when we plot these points, we've got 0, 3, about there, and we've got 2, 0, which is here. You can see how easy it is to connect those two and then just keep going. And now we have this nicely neat graphed line. Didn't have to go to the trouble of putting it into slope-intercept form. This is probably the quickest and easiest way to draw a line, is to find the x and y intercepts. The other way we were talking about was finding slope, and we didn't get into how you actually find the slope. So we've got this equation which says m equals rise divided by run. Notice I put rise divided by run. A lot of times you may hear teachers say rise over run, but remember that fraction bar doesn't mean over, it means divided by. So slope is equal to rise divided by run. And this is actually the equation for slope, how you actually find that. Now in our last problem we had, and I'm just going to go back real quick here so you can see it, we had these 2 points on our line. We had 0, 3, and 2, 0. So using 0, 3, and 2, 0, we could easily find the slope for that equation by taking your second y-coordinate, and we're going to call this our second coordinate, just because it's listed second, and this is our first coordinate point. And so we're going to take our y2, which is located here, so it's our second y, and we are going to subtract it from y1, which is here, which is 3, divided by our second x-coordinate, 2, minus our first x-coordinate, which is 0, and we end up with a negative 3 divided by 2. That is our slope for this past equation. Now, if you think about it, remember we said how you could just count out the slope. In this case, we would go down 3 and over 2. When you go back to our graph, you can see, and you can count this with me, if you go down 3, 1, 2, 3, you end up here at 0, 0, and over 2, 1, 2, you end up here. So down 3 over 2, that is the slope of this line, so that does check out. So just a way to find slope, if you know 2 coordinate points, you can use this equation. And it doesn't matter if this one was your first coordinate point or this one was your second coordinate point, as long as you label them and you make them consistent so that they go in the same order within your equation. On this one, I'd like for you to find the slope. You can do that again by using this equation here, right here. Y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So you might want to pause your video and see if you can find the slope equation for this line. Okay, I'm going to call this my first coordinate point and this one my second coordinate point, just so that I can keep them separate. So as I put in my y sub 2, it comes from this coordinate point, so that I've got a 6 minus 2, which is my sub 1. So on my numerator, I've got 6 minus 2. And then I use my x sub 2, which is 2, minus my x sub 1, which is a negative 4. And if you remember, working with integers, we always add the opposite. So I'm going to add the opposite here. You can do that here too if you want. So we've got 6 plus a negative 2, which is 4. We've got 2 plus 4, which is 6. And we will simplify this fraction into 2/3. So I have a slope of 2/3. Hopefully that's what you got. Graphing this equation, I'd like for you to do this for homework. We've got y plus 5x equals 2. And it says identify the x and y intercepts. So again, set your x to 0 to find your y-intercept. Set your y to 0 to find your x-intercept. Okay, this is all I have for you today. So we will look at a couple of problems that we had on this Smartboard activity when you come to class. Hope you're having a good week.